It's working. So as x approaches infinity, 1 over x, this is the graph of 1 over x. Can anyone give us the answer?
It's indeterminate, or D and E, because they go opposite directions. Oh, as it goes to infinity, I'm sorry, it's infinity. My bad.
Let's look again. It's okay. I know you're, Brian, you made a mistake because you didn't want me to feel awful for what I wrote here. Thank you. So you wanted to make me feel good for writing what I didn't want to write. Please look at the graph and tell me the limit.
As x approaches infinity, it seems to tend towards 0.
Thank you very much. Because y equals 0 is the horizontal asymptote. The same thing as if x approaches negative infinity, the function values get closer and closer to 0. Is this clear? Now, here's a question for you. What if I put a power here, like a power r, and r is a number greater than 0? I wanted it to be greater than 1, actually. If it is greater than 1, 1.5, 2, 3, 10, will the answer change?
I don't think so. I don't think it'll change.
Of course not. The answer will stay the same. So any power that is greater than 1, it will stay the same. Okay. So then now I'm going to come back to our problem. And I'm going to ask you, keeping in mind what we just said a second ago, I'm analyzing this limit again. Limit as x approaches infinity. Where will this go? Just this piece.
It's 0.
Excellent. Where will the numerator go?
To 0.
I cannot disregard negative 1.
Oh.
I can't. 0 minus 1 cannot be 0.
Oh, negative 1.
Excellent. Very good. Awesome. Where does this go?
Zero.
Very good. 2 divided by infinity to the third power. Where does this go?
Also 0.
Good. Where does this go?
3.
So the answer is negative 1/3. We will conclude that y equals negative 1/3 is a horizontal asymptote. For such a function, if it is to the right, it will also be to the left. It's a rational function. If you want to determine whether x approaches negative infinity, you will get the same answer. So the limit at infinity came up with a number that must be a horizontal asymptote. This is based on the fact that 1 over x, as x approaches infinity or x approaches negative infinity, is 0. The limit is 0. Feel free to choose anything. We have to choose one with radicals for sure, and anything else you'd like. I would like to present something like this, extremely important.
Can you do number 31?
31, okay. Let's continue with 31. Let me copy it and I'll stop sharing. Limit as x approaches infinity from the square root of x squared plus ax, a being a number, of course, x squared plus bx, b being a number. There's just not given to us. Okay, perfect. First step. So the first step was to plug it in. And then the second step is to simplify. By factoring. And that's what we did, and then we plugged in. So the first step, plug it in to see what it is. Because if the answer is 3, I'm done. I don't need to do any of this. So if I plug in and somehow I get 3 or 2 or 5 or negative 10, I'm done. There is no calculation required after that. Okay, so what do we need to do first for this problem?
Plug in.
Good. So the question is, where does this go? But before that, since x approaches infinity, inside the square root, which of these two terms is the most powerful?
The x squared.
Good. So where does this go?
Positive infinity.
Awesome. Where does this go? By the same principle.
Negative infinity. Get the minus.
Where does this go?
Infinity.
Good. And now what is this?
So it'll just be 0. So infinity minus indeterminate.
Indeterminate case.
So this is infinity minus infinity. We don't know which one is bigger. They cannot be identical. Who knows what it is? So this is an unknown situation. It has hope. No guarantee, but it has hope. Versus this one, which is dead in the water. Okay. Now look at this function and say, I think I know what I should do. And tell me, what is that? Look at the type of function this is and say, aha, or without aha, and just tell me what I should do. We've seen something like this before, and we applied that procedure on it.
The difference of squares? No.
Yes, if that's what you meant, rationalizing the numerator, because this is over 1. So now the numerator is over 1, and this has radicals. Good. So tell me what to write. And as you know, I can't write over there. So I'm going to write it here. Ready? Yes, the difference of squares. Yes, yes, yes. Conjugates, they're called. Perfect. What is it?
With the square root of 2 of x squared plus ax plus the square root of x
Excellent. Who was that?
Gia.
Thank you very much. Well done. You understand that this is 1. All this is 1. 1. It does not change the expression. It will change the presentation, the outlook of the function, but it will not change its value. Great job. Limit as x approaches infinity. And then after this, I just want to make a comment about something I saw in the homework. I don't want to forget that. Yes, can anyone give us the numerator? The denominator I can write.
The numerator would be x squared plus 8x minus x squared plus 6x.
If I write it like this, it's incorrect. What am I missing?
Parentheses.
Thank you very much. Excellent. Great job. Perfect. Good. Moving on. So this is limit as x approaches infinity. X squared minus x squared will go away, and I have ax minus bx. Ax minus bx in the numerator. And now we'll continue in the exact same way we just did the previous example. You already told me that x squared is the degree here. I mean, degree 2, so x squared is the leading term. Inside, we're going to factor out x squared. Please tell me what you write. Of course, in parentheses. And of course, the second step is identical. Because they are identical except a and b, which are constants anyway. So can anyone tell us what to write in parentheses?
We put 1 plus
Excellent.
a over x.
Great job. And 1 plus b over x. Great job. Who was that?
Isaac.
Isaac, thank you. Perfect. Okay.
Can you explain that part again, please?
Yes,
The denominator part.
it's this. I factor out what I need. So I factor out, in this particular example, I shouldn't factor x squared. I went to extreme just to explain. So by factoring x squared times 1 is x squared times a over x is ax. But I have to factor out the degree.
I got it. Thank you.
Yes, thank you. Okay.
Is there any kind of like tips and tricks for that? Because that doesn't come quick to me. That would take me a minute to figure
Must
out what to put.
factor out the degree. It's a must. I have to factor out the degree at any point in time. If the degree is 2, I have to factor out 2. If the degree is 3, I have to factor out x cubed. If it's 2, I factor out x squared. If the degree is 1, then I factor out x.
Yeah, I get that part, but just the things that are inside the parentheses, it just doesn't come as quick to me. I wasn't sure if there was.
Yeah, no, I don't know how to give
I
a
didn't know if there's any way to like cut a corner without like me doing some trial and error.
You just have to remember that if I have here power 1 and I remove power 2, 1 minus 2 is -1, so it's a over x. X to power -1 is 1 over x.
Okay.
So
yeah,
power
I'll have to go
1,
sharpen
I
that.
subtract power 2 is -1, so a over x.
Okay. Yeah, it's just something that I'm going to have to sharpen.
No, if you just redo these problems several times, it will click.
Right, that's what I meant. Yeah.
Oh yeah, oh yeah. Okay, moving on. I have to stop for a moment. We have to analyze one more thing that we did before, and I refreshed your memory on it. We used it, but let me do it again. If I take, because that's what I have, that's my next step. My next step here is to take the square root of x squared. So first of all, remember the square root of a times b is indeed the square root of a times the square root of b. Since we are here, let's also refresh our memory on the division. So this is true too, only for real numbers. So this is true for real numbers. And the square root of a plus b never equals the square root of a plus the square root of b. The same is valid for subtraction. This will be a terrible mistake to make. Okay, based on this, now I want to go back to the square root of x squared. When x can be any real number. Can anyone remembers the answer? Don't jump to conclusions, be careful. So what is the answer in this case? Super important to remember. Anyone?
Would it be square root of x times square root of x?
We want to simplify. I could use this, but then I cannot simplify this and I cannot simplify that.
Oh, I see.
It's not a mistake, but that's not what we're looking at. But it's correct.
Isn't that the absolute value of x?
Brilliant. This is a positive number. That's for the answer always has to be positive. But now, what do we know about this?
It has two outcomes.
Very good. So now, be very careful here. This is where I'm at. I have to take the square root from this and then the square root from this. I have to break it up using this property. So I have, because of course I wrote a lot in between, I have this circle, and I'll continue here with a circle. So you know where it's continuing. Okay. So I still have the limit as x approaches infinity. What can I do to the top? Can anyone tell us what you would do? Common sense. Remember what I said a long time ago? Factor and simplify should be two words. They should always be in the back of your mind anytime we talk about anything in math. So how do I arrange the top?
Factor of this.
Good. What is left in parentheses?
A minus
B.
Excellent. Good job. Great job. So now this, I'm applying the property. I have to write the square root of x squared and the square root of 1 plus a over x plus the square root of x squared times the square root of 1 plus b over x. Okay, next. The square root of x squared has two options. Not really, because this tells me which one to choose. Which one will I choose? In this example, it does have two options, but in this example, only one makes sense. Which one?
X.
Yes, this has to be replaced by x because x approaches infinity, which means the first branch. And this is replaced by x for the same reason. Okay, one more step. X approaches infinity. X, a minus b. X and x, can I factor it out, or do you want me to write it again?
Write it again, please.
Sure. So x the square root plus x the square root. 1 plus a over x, 1 plus b over x. So now we factor out x in the denominator. And we have the square root of 1 plus a over x plus the square root of 1 plus b over x. Perfect. What do you think I'm going to do next? I know you know.
The x's cancel out.
Because they're factors, notice that I factor them out. This is parentheses, this is parentheses. Now I'm ready to apply the limit, and the limit operator will be dropped because I apply it. Where does this go? And where does this go when x approaches infinity?
0.
0.
Good. Where does the numerator go?
Will it remain the same?
A minus b.
Minus b.
Good. Where does the denominator go?
2.
That's it. So y equals a minus b over 2 is a horizontal asymptote. Now I can guarantee you is only at infinity. How do I know? Because I used it to get this. Who knows what happens at the other end? But definitely it's not the same. So this is a horizontal asymptote at infinity only. When we started this problem, we got infinity minus infinity. Pay attention, please. A minus b over 2 has nothing to do with any infinity minus infinity. So that's why these are called indeterminate cases. Anything can happen. The answer is we have to work our way through step by step. Good pick. I don't remember who did this, but it was good. Okay, I want to make a comment because I'm going to forget again. I saw in some of your work, and I need to explain this because not too many, but it's very important. You understand? Okay, let me start a new